Good afternoon, guys. Welcome to the Coded channel. Today we are going to solve the problem number 2904, and the title of the problem is Shortest and Lexicographically Smallest Beautiful Substring. So we need to focus on the two words. First word here is shortest, and second one is lexicographically smallest. So first we need to find the length of the smallest substring, which is following this constraint. So we are given a string, binary string s and a positive integer k. A substring of s is beautiful if the numbers of ones in it is exactly k. Let length be the length of the shortest beautiful substring. Means the shortest beautiful substring means it follows the condition that it has exactly k number of ones in it. So return the lexicographically smallest beautiful substring of S with length equal to len. If S does not contain a beautiful substring, return the empty substring. So in that case, if S is not having a beautiful substring, means number of ones in the substring is not equal to 1 in any of the substrings of this string S, then we need to return an empty string. A string A is lexicographically larger than string B of the same length if its first position where A is different than B. A has a character strictly larger than corresponding the character in B. For example, A, B, C, D and A, B, C, C. So first character is same, B is also same, C is also same. So the character when they differ is C here and D here. So D is greater. So this one, A, B, C, D is lexicographically greater than A, B, C, C. Example, the input is S is equal to 100011001 and K is equal to 3. So we have to find the length of the shortest substring where count of ones is equal to 3 in this example. And then when we find like the shortest beautiful substring, there can be multiple of the same shortest length. So we need to give the lexicographically smallest of those. So I have written a code. Let's read it. So first I have initialized the count one variable with 0. It will count the number of ones in the array. Int n is equal to s dot size vector int count one. This is a vector which is storing the count of ones till that particular index. I have initialized that there are n plus 1 elements and all the initial elements are initialized with the value 0. So I am looping over the string that is s for int I is equal to 0, I less than n, I plus plus. If s of I is equal to 1 means that character is 1. So I am incrementing the count of 1 means count of 1 will definitely increase because this is the count of 1 in the string. Then count of I plus 1 is equal to count of 1. Why I have done this? Because the index 1 in the count 1 array will store the number of ones till 0. Okay, like if I am saying count 2 is equal to 5, so there are 5 ones till index 1. We need to exclude that particular index. Okay, now I have taken a vector string st. I will push all the substrings which are valid in this st. Now length should be initialized with n. We need to find the smallest length which is satisfying this particular constraint, that is beautiful substring. For int I is equal to 0, I less than n, I plus plus. For int j is equal to I, j less than n, j plus plus. By doing so, these two lines, these two loops, we are covering all the substrings. And I can do a nested loop because we can see the constraint s dot length is greater than equal to 1 and less than equal to 100. So we can obviously do nested loops. So if count of 1 j plus 1, count 1 of j plus 1 means in the that count 1 array minus count of I. For example, a particular substring that starts at I is equal to 0 and it ends at j is equal to 5. So j is equal to 5. So we need the number of ones up to 5 and starting from I equal to 0. So up to 5 means we have to, in the count 1 array, I told you that if we want up to 5, then we need to take up to count 1 of 6, which will represent number of ones up to 5 minus count 1. Means I am subtracting the count of ones before that particular I index from which the array is starting. If this is equal to k means the substring is having number of ones equal to k. Then string y is equal to s dot substring. Substring we are obtaining by the inbuilt function. I is the starting from which we are in starting index, and this will be the length j minus I plus 1. So st dot pushback y, we are pushing all the valid substrings into st. If y dot size is less than len, means size of this valid substring is less than len, that is n. So length will be y dot size like this. We will get the length of the smallest valid substring. Now string t is equal to empty, initialize it. For int I is equal to 0, I less than n, I plus plus t plus equal to 1. I am taking the lexicographically greatest string first of all. There cannot be any string that is greater than this. So I am initializing t with it. Now if for int I is equal to 0, I am traveling the st vector. If sti dot size is equal to len means it is the equal to the smallest length. Then I need to see string z is equal to st of I and taking that particular string. If z is less than t means I am getting the lexicographically smallest binary those. If z is less than t, t is equal to z like this. I will get the lexicographically smallest string with length equal to means shortest substring. Then if st dot size is greater than 0 means we are having at least one valid substring, then return t by this, otherwise return an empty. Means if there is nothing is valid, we are already given that you have to return a empty string. So we are returning empty string. Like this we can do this, and the complexity will be O of n square. Space complexity is also O of n, and I can show you my submission. You can see runtime is 0 millisecond and it beats 100%. So thank you. Please don't forget to like, share and subscribe. Keep watching.